Good. So how's everybody feeling?
Good.
A little confused.
A little what?
It's a little confused, but you know.
Why are you confused?
There's just a lot of information in the lectures, and it's hard to like retain it all and then like go into the studio to mix some stuff, and you start adding other materials to your glaze, and then like all of these other things happen, or I suspect will happen.
Okay, like what?
So I did a bunch of tests this week with this one Celadon I've been using, and I'm just using the base. And then I'm trying the different iron-bearing materials with it. So I did
You
like
mean
one.
like yellow ochre or like just red iron, yellow iron?
I did Barnard, Red Art, Newman Red, and I did 1 through 10% of those three. And then I did black iron oxide, yellow ochre, burnt umber, crocus mortis, iron chromate, and ilmenite.
You did 10% steps of all of those?
I did 1 through 5 for the oxides.
Wow. With all in one base?
Yeah.
Okay.
But anyways, so like adding Red Art or Newman Red adding it into the glaze, it doesn't act as like an oxide, right? It adds more alumina and silica.
It's mostly clay.
Yeah.
Yeah, most of those. I mean, I think Red Art is 6% clay. So they're nowhere nearly as concentrated as just straight oxide.
Okay.
I mean, 6% iron oxide, so that makes it 95%, 94% silica and alumina, a few other things.
Yeah, but I'm wondering if like that'll start to cause crazing or like weird things.
It actually wouldn't. Well, for the most part, it shouldn't cause crazing. It actually should eliminate crazing, but it depends on all the variables because the thing to remember is that. Hold on 1 second. Open the wrong thing.
Yeah, I mean, I plugged them into the UMF with like 10% Red Art and Newman Red, and like it didn't really seem to change like the silica alumina ratio or the fluxes at all. Minutely.
Right. With 5%, it's not going. I mean, it'll change the silica and alumina a hair, right? But nothing. Oops, just turn my camera off. But nothing drastic. With the red iron oxide, it will begin to change your fluxing slightly.
Okay.
But remember, on stall, so if you're adding clay, right? So say you've got a glaze that falls in the middle. If you're adding clay, you're basically moving up on a slant like this. Oh, great, of course, it has to draw in white. Okay, so it's sort of going up this way.
Okay.
Right. Whereas if you just add pure silica, it's just going to go directly to the right. Okay. And so it really, so like so say you've got crazing, and you're adding clay, it's going to move you out of that crazing region. It's not going to change your silica to alumina ratio immensely, but a small amount. As you bring in, something like red iron oxide, so here on the calculator, so if we go and plug in red iron oxide into this just generic 4321, right, up to 5%. So right now we're at 0.22 alkali metal, 0.78 alkali earth. We add in 5% Rio, and it went down 0.02 alkali metal, and up 0.02 alkali earth, and our silicon alumina levels went down. Alumina went down 0.02 again. So yeah, I mean they're minor changes, although those can have an effect. We're going to talk about those in a couple of lectures of what sort of moving around will do to color. But you know, for the most part, it's a minor effect.
Mhm.
So how did the results look? Are you still waiting for them?
I'm loading a kiln today.
Okay. Yeah, I can't wait to see those. That's going to be great.
Yeah, I'm pretty excited. Yeah, it'll be good to see what they do.
Cool. Jess, how are you doing?
Good. I got my first round of Cone 6 tests out.
How'd the 3185 work?
It was alright. I picked through there until I found, you know, non-balled up gross
Right.
rocks.
I am told there is new material in there now.
Okay,
You know.
cool. Yeah, because I asked him about it, and he said, well, you wouldn't throw it out in your own studio. You should... I was like, well, I don't know.
Yeah, well, it's also his job to keep high-quality material supplied for our community.
Right.
So.
So some of them are weird, like I kind of knew this one. I don't know if you can see these.
Nice crawl.
Right? That's the
Gonna be
magnesium
good.
matte one.
Yep, that would do it. Ooh, hold on, I'm going to make you the presenter so that everyone can see. Okay, you're the presenter now.
Aha. Okay, so should I start with my first two?
Sure.
They don't look like much because they're clear. You know, you can't really see colors. But the
The
gloss
clear-
and the there's no color in them.
Mm-hmm.
The gloss and the matte came out nice. They feel nice.
Is the matte? I can't see the texture on the matte. Does it look? Is it matte?
I think so.
Okay.
It's a little shiny, but I think it's okay.
Okay.
Those were the two you gave me, and then these are my barium ones. So this is the gloss with barium in it.
Mm-hmm.
I don't know. The sun's behind me. Wow.
Yeah, it's a little hard with the backlighting.
The gloomy, gross outside's behind me, I should say. No sun. This is the matte, and this feels kind of chalky with the barium in it. The gloss is nice though.
Mm-hmm.
And then this was the magnesium ones.
Mm-hmm.
So the gloss is kind of I want to say snotty.
That's what happens with magnesium.
Okay.
And we're going to talk about that in next week's lecture, where magnesium it feels thicker, and there's an interesting thing that as we go down the periodic table, as we go from magnesium down to barium, the glazes will tend to get glossier.
Okay.
And so magnesium will be snotty's not a bad way to describe it.
Yeah, it's kind of snotty.
Magnesium
I know that's
is
gross, but
no, it's apt. You know, and in general, like you can see that trend. Like again, you can't see this, but like this is a barium gloss, and it's super duper glossy.
Mm-hmm.
You can see the reflection out my window right on the tile, and that goes with the increasing size of the RO molecule. That they do actually get smoother as you go down.
Okay. Yeah, because my barium gloss isn't as shiny, but it feels different.
Right. Well, again, that may be the
Nice.
tweaking of the formula. It might be the 3185. You know.
Okay.
Those types of things.
Let's see. And then, oh, little guy. And then the zinc gloss got kind of weird, kind of veiny. You probably can't see this. And it would help if I showed it to you.
No, I can't see that.
It's veiny, I
It's
guess
veiny.
is the best way to describe it. And the zinc, no, that's a zinc matte. The zinc gloss is nice. Little glossier, actually. And then my two strontiums are, the matte's really chalky, but the gloss is more like a matte.
Yeah, there's something going on with the strontium.
Right.
And I've spoken to Keith about it, and I don't have an answer, but I think unfortunately that we may have to just throw out using strontium for a while because it's just it's super wrong, and I don't know what's wrong with it, and it's definitely the material, and he sort of I asked him about it last week, and he sort of shrugged his shoulders, and
Right.
Is it a problem it coming from the manufacturer or
yeah,
like
it seems that way. Okay. Of course, he was asleep until 5 minutes before we started. Yeah, it's something in the manufacturer. The chemistry is not right. And if I don't know what the chemistry is, or if we don't know what the chemistry is, then it does us no good because the formulas inherently don't work until we find out exactly what the chemistry is.
So, like, if you typed a glaze into the UMF with strontium, so like the UMF has like strontium's chemical makeup, but the strontium in the lab has a different chemical makeup.
Yeah, and it's a real pain because strontium carbonate should be super simple because you literally just take the molecular weight of strontium, the molecular weight of carbon dioxide, because that is all that's in it. It's a very pure material, so you should be able to just guess. But if it's not doing that, it means it's contaminated somehow. But if we can't track it, if the manufacturer is not admitting to the issue, there's nothing we can do with it. So we need to send it out for chemical analysis, and I was asking Keith about it, and he was sort of like, yeah, not my job, man. So, yeah, well.
Great.
So I need to talk to the department about getting that done. Okay. And did you do color tests this week or just the bases?
No, just the bases.
Okay.
But I did do that copper salt that you had sent me, that you transferred over for me, and it came out really nice.
Oh, yeah?
I forgot to bring it with me.
Okay.
But I can take a picture of it. It's nice.
Okay, good.
I was very happy.
I will talk about so obviously it's a little bit hard to look at test tiles. In the future, and I know it's another extra step, but what I'd really like for you guys to do is to try to scan your tiles so that we can, and then post them on Blackboard. I'll make a little area where we can post things so that we can just pull up the images and share them so we don't have to fight with the backlight.
Okay.
And literally, you just throw them on a scanner. And we are currently, Linda is trying to get us actually our own little computer cart where we will have a computer and a scanner that's like just for us.
Cool.
But we're still working on getting it. It's in the works when I last talked to her last week. But like literally, if you've got a scanner at home, just drop them on the scanner and just scan them like a picture.
Okay.
And then we can post those on Blackboard, so we can all look at them super easy. Okay.
So cool. Colorant test. How should I go about that? How would you recommend I go about that?
So what do you want to look for?
I like blues and grays and like cream, tan, whites.
Okay.
Is that a good description?
Well, let's start with the whites and build from there.
Okay.
So let's say trying maybe just 2 simple tests of going with. Okay, Ezra, really? You have to do this now. You slept all morning, and then now you have to do this. Let's just do some tests where we say try 3 different opacifiers.
Okay.
So let's try Zercopax at say 2.5, 5, 7.5, and 10%, so 4 different increments. Let's try titanium dioxide.
Same.
No, do titanium dioxide at 1.5, 3, 4.5, and 6.
Okay.
And how about we try tin, and you're going to have to get Conrad to procure you tin if we don't have any yet. Okay. And do that at 0.5, 1, 1.5, and 2.
1.5 and 2. And should I just use that base gloss and base matte glazes?
For this test, yeah.
Okay.
Actually, why don't you... Actually, no. Let's leave the matte for the moment.
Okay.
And let's do it with each of the gloss glazes you've got that came out successfully. So what,
Okay.
the calcium, magnesium, zinc. You said the barium was iffy?
Barium, zinc, and, well, the strontium isn't really. I would say barium and zinc, and then that base gloss you'd given me.
And then the base was calcium.
Yeah.
Okay, do those 3.
Okay.
I mean, you can do the matte base too if you want.
Okay.
But go with the glossy ones for now.
Yeah, because I think there's only 3 mats that I'd want to do. Well, the
Right.
strontium we're Xing out for now, though, right? So
Yeah, it's just not worth the
okay.
legwork.
Yeah, because this one, I mean, this is cool, this crawly one, but I don't know what I'd...
Well, it's also going to consume the color.
Oh, okay. So don't worry
We're
about
going to talk... Crawling glazes come up when we get into special effects in a few weeks.
Okay.
And that's a very predictable effect that you got.
Right.
You know, I wasn't sure if you had hit it exactly where you were working because it moves around a little bit, but working in that matte region in both MGO and zinc are very likely to crawl.
Okay.
And so if you go and look at Rob Sutherland's, who was a grad about 10 years ago, if you look at his pots, he was using zinc crawl glazes that we had developed.
Yeah, right.
You know, so it's a thing, it's a controllable thing, it's a predictable thing. You have a little bit high clay in an MGO base.
Okay. Gotcha.
Okay, good.
Cool. Good.
Beth, how you feeling?
Okay, I did my test. I have them
Yeah?
right here. Yeah.
How they look?
I got like a few that I really like.
Mm-hmm.
Yeah. But some of them are, I don't know. So I got here, wait.
Hold on, I'm going to make you the presenter. Hold on.
Yeah, so number 10 turned out really nice. Or I think it is. I don't know if it's, but it's like a really nice mat.
Mm-hmm.
Cool.
Good.
It didn't do too much. And it feels really good.
Great.
I really like that one. That was zinc oxide.
Hold on one second. I'm going to pull up your formulas here.
I have them right next to me too.
Classes, Glazes 2, Labs, Beth. Okay, here we go. So, yeah, number 10 was a zinc mat. And yours didn't crawl, so that's good to know. Again, that's a glaze that could crawl very easily.
Really?
If you increase the clay content a little, it could definitely crawl. What else worked out for you?
Well, there's one that looked like glitter, and I don't know if I just dipped these two, like, not enough.
Which one was that?
Number 6 looked like glitter.
Yeah.
Shiny.
Yeah.
Oh. Yeah.
So let's see. You're at the calcium mat. Yeah. That's pretty heavily matted, and you can tell that it's a true mat because it's running at the bottom.
Yeah.
So that's great.
Does that mean it's like does that mean it's overfired?
It's slightly overfired, but it's not a huge deal. It's not like a deal breaker. Did you spit your pip? How'd the glosses come out?
This one like crazed a lot. Did we do glasses? I thought we only did mats. No.
How many bases did you make?
10.
Yeah, so the first 5, 1 through 5, are gloss. Okay.
Number 1 crazed, and that was...
Yeah, that's to be expected.
Yeah. Why is that?
Well, it comes down to the porcelain.
Mm-hmm.
Porcelain tends to have... Ezra, hold on. Okay, where's your pip?
Oh.
Okay, well, if you didn't... There it is. Porcelain has a lot of silica in it.
Mm-hmm.
And silica has a very high thermal expansion.
Yeah.
And usually our glazes have lower thermal expansion than our bodies.
Mm-hmm.
And so if the clay's got a lot of thermal expansion and the glaze has a little, then it crazes to relieve that stress.
Mm-hmm.
So actually that'll come up extensively next week. Next week.
We can use sorry.
No, go ahead.
You said porcelain has lots of silica, so there's lots of thermal expansion.
It's a complicated relationship because if it has undissolved silica, it gets high thermal expansion.
And that's what porcelain has and does?
Generally, yes.
Okay. And then glaze is kind of the opposite.
Well, glazes can have a thermal expansion that is either high or low. It depends on the specific glaze.
Okay.
Okay, but that's why thermal expansion literally depends on what clay body you're using and the glaze, because you can put a glaze that theoretically crazes on one body and shivers on another, because it's just about what is the thermal expansion of that clay and what is the thermal expansion of that glaze. Okay, so if your clay body has a lot of undissolved silica, it's going to have a very high thermal expansion, and then if the glaze is low, it will craze to relieve the stress.
Okay.
Okay, and we're gonna this is a huge subject that we'll talk about a lot next week. So we will really go into depth about it.
Okay.
What you got, Beth? That one looks crazy.
That's on stoneware. That's the same thing.
Oh, really? Interesting.
It's really thin, though. I don't think I dipped them long enough.
Yeah, it looks a little thin.
Yeah. Number 5 is like kind of. Or do you want to go like 1, 2, 3, 4, 5?
Yeah, go 1, 2, 3, 4, 5.
Okay. There's 2.
Okay.
Here's 2. That crazed a little bit.
It looks like a pretty good surface, though. I mean, especially considering that's MgO, and we were just talking with Jessie about her MgO being snotty.
Yeah, and it did craze a little when I'm looking at it in the light.
Yeah.
1, 2.
So this is your next one's your strontium, which, that.
Even on a stoneware.
Yeah, it's okay. A little thin.
Well, this is the
for the MgO.
Yeah.
Yeah, I mean it performed better. A little thin still. Okay. Oh, Ezzy, why you gotta be a drama llama?
Maybe it's weird. There is like, I don't know. The surface looks.
It's okay. This is number 3.
Yeah.
It's that strontium. It's not going to participate well.
Looks like under 5 or something.
Yeah, it is because my numbers are wrong.
Oh, okay.
Because I don't know what's in that strontium. If I could get that analysis, then I could adjust things properly.
Yeah, analysis. Who does that?
There's a laboratory in Vancouver, and you send them a sample and $50, and they'll run an analysis on it.
Oh. Is that like all the strontium in the U.S.?
I don't know who the various suppliers are, and especially with materials now, like a lot of materials. Oh, yes, a lot of materials are coming in from overseas. So it very well may be, that whoever the supplier is has started sourcing from somewhere else, and the chemistry's not good, and you hear that about overseas supplies all the time, that they'll just substitute materials or not perform up to spec. So along with you as well, I'd say just ditch the strontium.
Okay.
Unless your mat came out perfectly, but it seems like it's all out of whack. Okay.
Number 4.
Do we need to? You're gonna narrate? Really?
Yeah, he's commenting.
Looks okay.
Commenting on my surfaces.
He is. He has major opinions about glossiness. It looks okay. Not great.
Yeah.
Oh, so that one's your barium?
Yeah, that's a barium.
Yeah. And then did we look at your zinc? That's your zinc. Yeah, that looks pretty good.
Yeah, so that was kind of a nice surface too, but I think I prefer, like, it bubbled slightly. I don't know, it's like pinholing maybe.
Was that there before you fired it?
I have pictures.
Oh, you have pictures of before you fired?
I believe so. I think so. Maybe.
Ooh.
Maybe.
Just because zinc, the reason sort of talking about that crawling that Jess had and sort of saying that you might see it, of zinc and magnesium both have sort of application issues that it packs sort of poorly, which tends to leave things that look like pinholes.
Oh, yeah. I mean, they're not like true pinholes, but they're definitely like teeny tiny little, dots.
Mm-hmm. Yeah, they're not so bad.
Pinholes, right?
Well, what's the definition of pinholes? That is such a vast discussion of what's a pinhole versus what's a bubble, and they're not the same thing, and
Yeah.
lots of stuff that's sort of a big conversation.
No, it was number 5. Oh, number 6 is the glitter one. I like that.
Yeah. That's really nice.
Isn't there? It looks like it crazed though.
It probably did. Matte glazes can absolutely craze. A true matte glaze absolutely can craze because it's a gloss with crystals growing in it.
So are those all the crystals growing in it?
Yeah.
Whoa! No way!
Yeah.
Oh my god!
Way.
That's why it's so
sugary. Yeah.
Oh my god. Okay. 7. 7's Oh, 7 is the magnesium carbonate. Yeah. It reminds me of
you're getting ready to crawl.
An orange peely.
Yeah. So it literally, this is like one step before Jess's glaze. If you took that and added some more clay to it, it would turn into what Jess has.
Okay. Cool. And this is supposed to be matte.
This is 8?
Yeah. Or 7.
7. Well, and that's the problem of when it starts to crawl like that, it's changing its chemistry slightly, so it'll actually go glossier.
Oh, okay.
So we need to tweak it a little bit to turn it matte.
Mm-hmm.
Some of the rules, and this is sort of where we're going, are the rules really start to get wonky, as we move around and change things. So.
Here's strontium again. It looks underfired.
Yeah, and it is. I'm sure it is.
Fired. Feels underfired.
Okay.
And then there's 9. Barium. It looks like a rock.
Hold on, I'm going to pull up the chemistry on that. Yeah. It actually probably could use a little bit. Okay. It's actually, again, it's probably really heavily crystallized.
Yeah.
So it could probably actually use a little bit of silica.
Mm-hmm.
Okay.
But the surface just looks like a stone. Like it looks really, really rocky.
Yeah.
That's kind of
well, and that's because, it sort of is. A stone is crystallized silica, and that's crystallizing silica. I might take this recipe and add in, I think probably 5% flint to the formula you've got on your barium matte. And it should just be more glaze-like and less stone. Okay, what's wrong? Very sorry about this, you guys.
It's alright.
Oh. I'm having a tough time, I know.
This is the strontium. It's the strontium.
Make me sad. Strontium sad. Okay, so and then do we see the zinc
And then we
already?
looked at 10, and then 10 is like
10.
my favorite. It feels so smooth and stony.
Okay, so for you, I would take 1, 2, 4, 5, and probably 6 and 10. Okay. Please stop whining. Please stop whining. Yeah. I know. Oh, now you're excited. Ha ha. I know. Yeah. Yeah, you made that look unprofessional. Yeah. You want to eat? So Beth, what we should be looking at for next is to take those 6 bases.
Sorry, what were they? 1, 2.
No. Okay, please stop. Stop. Take those 6 bases and go and pick out. Let's start with 5 stains that you like.
Okay.
And pick them out and talk with Conrad and have him get small samples of those 5 stains.
Oh, I went and bought a bunch of stains.
Oh, you did? Oh,
yeah.
Okay. Okay. Just try them. Try each of those 5 bases with a stain.
Okay.
I'd say try 5% and 10%.
Mhm.
And so you only have to mix each glaze once. Mix in 5% of the stain, mix it up, apply it, and then add in another 5%, mix it up and apply it.
So they're 1, 2, 4, 5.
So that's 6 times 2 is 12. So you'd have 12 tests for next week.
No, the numbers that I'm testing.
Oh, 1, 2, 4, 5, 6, and 10.
Okay, cool. 3. Oh,
Okay.
poor strontium.
I know. Well,
Strontium.
yeah. And it is too bad because strontium's amazing. And we'll figure it out eventually, but you know.
Well, can we not get our vanadium yellows until we have strontium fixed?
Wah wah. Wah wah. No. No vanadium yellows. Yeah, like I said last week, Courtney from 2 years ago, she tried an entire semester and got literally nowhere because the strontium's just.
It's weird.
Yeah, well. Yeah, I wish I knew what was going on. We'll figure it out eventually.
Yeah.
You look like you're thinking of something.
No, we were playing with strontium in high school,
Mhm.
and it didn't look under fire at the surface.
Right. And it shouldn't be. When it works, it's perfect. You know, that yellow. This yellow is super duper glossy.
Uh-huh.
You know, it's super duper glossy. It works just fine when the material is good, but when we've got okay.
Those materials are probably like super old though. Because like no one uses strontium or our normal base glazes that I would mix up, or not base glaze, video recipes never call for strontium. So
right? Yeah. It's not a material that's used a lot.
Yeah.
Okay. I'm very sorry about this, you guys.
It's alright. Poor little guy.
Yeah, I know. And, I'm about to do something. I'm going to cover up the camera. Talk amongst yourselves for about 2 minutes. Hold on.
Hello?
Hello?
Get up!
I wish strontium worked.
I know.
That's so weird. I've never seen that.
Are yours really chalky, Beth?
The strontiums, yeah.
Mine are too.
Totally they're under fire. 8 and 3.
Oh, not too much. You just called?
Did you fire to 10?
Oh shit. Oh well, I'm
No,
in
6.
an online class right now. Yeah. We're
6.
nice. Yeah.
Beth, do you need mason stains from Conrad? I'm gonna email him right now.
Oh no, it's okay. I have
Okay.
I went shopping.
Nice.
I'm back. Sorry about that. I had to deal with a situation. Hopefully this will calm me down.
Oh.
Okay. Okay, so we've got your stains. Jess, we've got your next step.
Yep.
Right, did we talk to your next step?
No.
Oh, I'm so sorry, guys. Okay. Go ahead, Greg.
Sorry, I'm eating a sandwich.
No, that's okay.
Well, what I was gonna try to do, before this kiln I'm firing today, but it's not gonna happen. I was gonna try to reformulate, or just change a little bit. This one Celadon I've been using, it's a Andy Grayman Celadon.
Oh yeah, the one we looked at it last week, right?
Yeah, I was gonna try to get it to not craze by adding silica.
Okay, hold on one second. Let me plug this in, just because I failed to save it last week, and I should have.
Oh, I have it all typed in the UMF on my computer.
Okay. Can you screen share it?
Yeah. Screen share.
It's the green arrow. It's the second box down on the left.
There. Can you guys
There we go. Yep.
see it? Oh, here we go. Yeah. So the silica to alumina ratio is like pretty off, and also the alkali metal and the alkali earths is kind of off.
So the ratio in and of itself isn't off.
Oh.
9 to 1 or 9.7 to 1 is fine.
Okay.
Ezra. Stop.
And that 9.7 to 1, so there's more. Excuse me. That's gonna make the glaze. That means that the glaze is gonna be like more viscous and run more.
No, it's really so with the 9.7 to 1. When we look at the silica to alumina ratio, we're really just determining what are the inherent qualities of that glaze. Okay, so it comes back to a matte glaze is 5 to 1, a gloss glaze. Although 7 to 1 is sort of listed as ideal. I am so sorry. I know, this is painful for all of us. A 7 to 1 is ideal, but we'll talk about next week's lecture that you can really have anywhere. Okay. From a stop.
He's so tiny.
Well, yeah.
So small.
Yeah. Who's tiny? Sorry. It's that anywhere from 5 to 1 to 12 to 1 can be perfectly glossy. Okay, and so it's really just telling us how glossy it's going to be. But anywhere in that region is fine. And looking at the rest of this glaze, okay, so you noted that the flux ratio is off.
Wait, can you guys see it?
Yep, can see it just fine.
Okay.
So we're looking at it 0.15 to 0.85. Okay, then eat. If you're hungry, then eat. Okay, trauma. Honestly, at this point, I wouldn't worry about the flux ratio being off because actually he's doing you some favors as far as glaze fit. Again, is gonna come up in this week's lecture. Ezra. That actually one trick to eliminating crazing, although I talk about how great 0.3 to 0.7 is, if you actually increase your alkali earths, it will help to reduce crazing because sodium actually has very high thermal expansion. And so he's doing a couple of things that are interesting. He's got a sodium base, but he's also, put a little bit of lithium in there, which is trying to reduce thermal expansion. He's increased his ROs, trying to reduce thermal expansion, using both the strontium and the wollastonite. but so really, if you're still getting crazing, you're absolutely right that it comes down to adding more silica and alumina to try to move up on Stull, because he's actually done all the other things that you can do to reduce crazing.
Okay.
So I think that you're right. Let's see. So we're at 24 flint, and usually the method that I find to keeping the same silica to alumina ratio while trying to eliminate crazing is you want to add about 1.5 parts of clay to 1 part flint. So from here you'd go up to like 15.6, 16. So you go to like 17.1 Rawlig and 25.7 flint. And then just increase incrementally. You'd add 1.5 parts of clay and 1 part of flint. So right now your Rawlig is at 15.6. So you'd add 1.5 to that, which would be 17.1. And you'd add 1 flint, which would make you 25.7.
Okay. Yeah, I was worried about. Well, I figured before I tried to do this, I should type it into the UMF, and I saw the silica to ratio, or the silica to alumina ratio is kind of high, and I was worried what would happen if I added more silica.
If you added more silica, it would actually be a problem. That's why you need to add silica and clay.
Okay.
Okay, so one of the main things when altering glaze is you really want to try your hardest to keep that silica to alumina ratio the same while changing the actual amounts.
Okay.
And so by doing that, you can keep the same general texture while eliminating crazing, or if you've got running, you would reduce running.
Okay.
And actually, that will come up in the lecture that got posted today. We talk about how to do that.
Okay.
Okay.
All right. Yeah, I figured I was gonna try to do that last night, and then I was watching the lecture last night, and you started talking about crazing and adjusting your ROs and R2Os to reduce crazing, and so I figured I would not do it until this week.
Well, and it'll come up in this week's lecture that there are really, or I'm sorry, next week's lecture, that there are several ways to reduce crazing, but they each have their own benefits and detractions. The first one is always to increase your silica and alumina, and I got to emphasize that, is that you really have to do both of them.
Can you add alumina oxide into your glaze?
No. Great question. No, you can't, because it will not melt. So it just sits there and dries up your glaze.
Oh.
Okay? So the only way you can add alumina into your glaze is to add clay. Which is why I was saying to add clay and flint. Technically, you can't add feldspar, but you add in feldspar, and then you're starting to change your fluxes, and you don't want to do that at this point. So clay is the only source for alumina that we have that will dissolve, that will actually melt. Okay, you're doing well. Let's relax.
And so you're saying to try 17.5% Rawlig and then 25.7 silica?
Yeah, but that's just the first step.
Yeah, and then you slowly do increasing those, do maybe a little line blend, I guess?
Yeah, exactly.
Just keep adding 1%.
1.5% clay and 1% flint. Yeah, and do, so you just did that one. See, it didn't go up a ton when you made that change. So, maybe you want to try it, instead of starting at 1.5 and 1, maybe try it at 3% and 2.
Okay.
Because then you'll make bigger jumps. Because you went from, you were at 0.34 alumina up to 0.35. You're moving, but not very fast.
Yeah. Okay.
Okay?
All right.
Okay.
Thank you.
Sure. So we will look at the iron test when I come up to Alfred. I will be up, I think it's in 2 weeks.
Okay.
Or is it 3 weeks? So we'll look at those iron tests. I've heard they're interesting. So we'll look at those when I come up. But until then, we'll just keep plugging away on what you're doing. Any other questions for me? Nope.
No.
Okay, everybody got their next steps?
Yep.
Keep playing, keep trying. So yeah, just for next week, before we come in, I will set up an area on Blackboard where we can post your scans, and literally just go and drop your tiles on a scanner, and grab a quick do the highest resolution scan you possibly can, and just run a scan so that we can just pop them up on the screen share instead of having to hold them up to the camera.
Cool.
Okay.
Wait, Matt, one more thing.
Yeah,
I remember last week during the Hangout, you showed me, or you pulled up this guy's website who had done a lot of it was like Chinese glaze research. His name was Philip.
Glaze.
Richard?
Hold on one second.
I did not write down his name. I don't know why.
His name is Derek O. Actually, I don't know how to pronounce his last name. But the website is glazy.org. Here, I'll put it in the chat.
Maybe Ezra just likes to watch himself.
Yeah, is that it? Oh, who's that baby? See, you're all cute when we're done.
Oh, and Nigel Wood.
Oh yeah, Nigel Wood, and that's the Chinese glazes book that you can get. That's in the library.
Is that the Celadon Blues?
Well, no, there's 2 books. One is Chinese glazes, although the one in the library, talking with a pip in my mouth, the one in the library has a different cover than this. But Nigel Wood's Chinese glazes, he's got a ton of Celadon stuff. And then Robert Tschane, which is Tschine, he's got a book called either Celadon Blues, Iron Blues, or Those Celadon Blues. They're all the same book. They've just been reprinted with different titles.
Okay.
And so so that's another good place to start collecting recipes. And like I said, I mean, even if you don't do them, I would go and collect as many recipes as you can and just plug them into the spreadsheet so that you can see the trends that people are doing with different Celadons. Okay?
Okay.
Well, I'm glad some of you have smiles. I so apologize for...
Oh,
that's fine.
it's all right.
You guys are so flexible. I really appreciate it.
Yeah, no problem.
Okay, any other questions
No
for me?
worries. Nope.
Okay. Go out and make some cool glazes, you guys. If you have questions, don't be afraid to email me.
Cool.
Okay?
Okay.
Later.
All right,
See ya.
thanks, Matt.
Bye, thank you.
Bye.